Welcome to the College Algebra Midterm Review. We'll start off with problem number 1, where I'll ask you to solve 3x minus 5x plus 1 is equal to negative 3x minus 4 minus 6. First step is we will distribute the negative. And remember, if there's no number in front of the parentheses, we could just put a 1 there. So we get 3x minus 5x minus 1 is equal to negative 3x plus 4 minus 6. Combining our like terms, and then bringing the 3x to the other side, and the 1 to the other side, we just get x is equal to negative 1. Next problem we'll solve is a compound inequality, so negative 3 is less than or equal to negative 7x plus 1, which is less than 11. Now, when we're solving a compound inequality, we want to make sure we do the same operation on both sides. So first, let's subtract the 1. From both sides, and we get negative 4 is less than or equal to negative 7x, which is less than 10. And then we have to get rid of the negative 7, so we have to divide every side by negative 7. And remember, with inequalities, if you divide by a negative, you have to switch the inequality. So this would be 4/7 is greater than or equal to x, which is greater than negative 10/7. The way we put this in interval notation, remember that if you have a less than or a greater than sign, we convert that to parentheses. Less than or equal to and greater than or equal to, we use brackets. The low value also goes on the left. The high value goes on the right. So it makes sense to rearrange this. So it just says negative 10/7 is less than x, which is less than or equal to 4/7. And then in interval notation, just negative 10/7, comma 4/7. And we put the 4/7 in brackets. The next problem we're solving, problem number 3, is the absolute value of 2x minus 7 minus 12 is equal to 13. And when we're solving absolute value equations, we want to make sure that we isolate the absolute value. So if we're going to do that, first step is we could add 12 on both sides. And then we break it up. One side we keep exactly the same, meaning we write 2x minus 7 is equal to 25. And on the other side, we take the opposite of the right, which gives us 2x minus 7 is equal to negative 25. Solving now, you could add the 7. We get 2x is equal to 32, or x is 16. And then on the other side, we could add 7 to get negative 18, and x would equal negative 9. Our next problem, what I'm going to ask you to do is I'll ask you to write an equation of a line perpendicular to 3x minus 5y is equal to 15 through the point -3, 5. So we do have a couple different ways we could do this. We could use slope-intercept form, which is the most popular, or we could use point-slope. However we do it, first thing we need to do is to get the slope. So I'm going to rearrange this 3x minus 5y is 15. Let's bring the 3x on the other side, and then divide by -5. And we get y is equal to 3/5 x minus 3. Now, the slope of this line is 3/5. So if the question asked us to write a parallel line, we would also use 3/5. But because it asks us to write a perpendicular line, we're going to use -5/3. So going back to our strategy now to write our equation, y is equal to mx plus b, we're going to use the slope that we discussed for perpendicular, the x value of the point that we're given, and the y value of the point that we're given, and we'll go ahead and solve for b. This would equal 5 is equal to just 5 plus b. If you subtract 5 on both sides, you get b is equal to 0. And then tying it together to give us an equation, we get y is equal to our perpendicular slope plus the b value. Now in this case, the b value is 0, so you don't have to write plus 0, you could just write it like this. Next, question number 5, it asks us to solve 3x squared plus 11x is equal to -8. Now when we talk about solving equations, first thing we did is we said we have to make it equal to 0. So I'm going to go ahead and bring that -8 over and make it equal to 0. Once we do that, if it's just a basic equation, like x plus 2 is 0, we could just say x is -2. But some of the more advanced problems we might have to factor. And then we set those factors equal to 0. Remember, we talked about GCF factoring, we talked about grouping, trinomials, and special cases. And then, like I said, once you factor, you make the factors equal to 0 and solve. So let's see how that plays out for this problem. In order to factor this, we multiply 3 times 8, which is 24, and we look for numbers that add up to be 11. So 8 and 3 multiply to be 24, and they add up to be 11. So instead of writing 3x squared plus 11x plus 8 equals 0, we could break up this 11x to be 8x plus 3x. And then if we cut it down the middle, we could factor out a GCF of x here. We get 3x plus 8, a GCF of 1 in the second grouping. Taking out the GCF of 3x plus 8, we're left with x plus 1. And like I said earlier, we make our factors equal to 0, because if you have an equation and two things are multiplying to equal 0, that means one of them is 0. So if x was -8/3, our equation would be 0, and if x was -1, our equation would be 0 as well. Next problem, we'll call it 6a. I'm going to ask you to multiply 2a minus 3b times a squared plus 3ab minus b squared. So a binomial times a trinomial. Well, what I'll do is I'll multiply 2a times each term, or 2a times a squared plus 3ab minus b squared. And then I'll multiply negative 3b times each term. We're going to have a lot of moving pieces, so just make sure you're careful with the signs. Remember, anytime you multiply the same bases, we add their powers. So this would be 2a to the third plus 6a squared b minus 2ab squared minus 3a squared b minus 9ab squared plus 3b to the third. Doesn't look like we have any more a to the third power or a cubed. It looks like we have an a squared b here. We also have an a squared b here, so I'll combine those to get 3a squared b. We have an ab squared. We have an ab squared. This would be minus 11ab squared. And then we're just left with the 3b to the third. Next, we'll multiply 2x plus 5 to the second power. Now, please make sure you don't distribute the exponent. What we have to do here is we have to do 2x plus 5 times 2x plus 5. So we'll do 2x times 2x plus 5, just like we did earlier. And then we'll do 5 times 2x plus 5. And then combine our like terms. So this will give us 4x squared plus 10x plus 10x plus 25. Or combined, we get 4x squared plus 20x plus 25. Next problem, number 7, I'll ask you to simplify 3a to the third, b to the second to the fifth power times a to the third, b to the fourth power. Now, if we have a base with no power, you could just put 1. And one of the properties that we discussed is a power to a power, you multiply the powers. So this would just be 3 to the 5th, a to the 15th, b to the 10th, a to the 12th, b to the 4th. And then now that we multiplied those powers, now we're multiplying bases, so we add their powers. We just get 3 to the 5th, a to the 27th, and b to the 14th. Problem number 8, I'm going to ask you again to simplify. Let's say we had 2 times x to the negative second, y to the third, all to the negative fourth power, divided by 4, x to the negative third, y to the sixth. Now we have a few properties worth reviewing. Remember, a power to a power, you multiply. Bases being multiplied together, you add. Bases being divided, we subtract. And then anytime you have a negative power, what we do is we take the reciprocal of that expression. So let's go ahead and first distribute this power to a power. This becomes 2 times x to the 8th, y to the negative 12th, over 4, x to the negative third, y to the 6th. I prefer to break this up into individual fractions. So 2 over 4 is just 1/2. 8 minus negative 3 is x to the 11th. And then negative 12 minus 6 is negative 18. So if we convert these to fractions by putting them over 1, it looks like the y needs to go to the bottom. So we just have x to the 11th over 2y to the 18th. Problem number 9, we have a system of 3 variables. So we have 3x plus 4y minus 2z is equal to 14. 2x plus y plus 2z is equal to negative 9. X minus y plus z is equal to negative 9. Now the idea with systems with 3 variables is we want to go from 3 equations to 2 to 1. So let's choose these 2 equations, and what I'm going to do is I'm going to add them together, and that'll eliminate our z's. Remember, when we're doing elimination, we want to get the same number, opposite sign. And then next, I'll use these bottom 2 equations, and I'll eliminate the z's by multiplying this bottom equation by negative 2. Looks like the x's actually cancel out, and we get 3y is equal to 9, so y would be 3. If y is 3, we could put it in over here. So instead of 5x plus 5y is 5, we said that y was 3. We get 5x plus 15 is 5, so 5x would be negative 10. X would be negative 2. And then to finish this up, we could go ahead and solve for z by plugging x and y into one of the other equations. So if x is negative 2 and y was 3, negative 2 minus 3 is negative 5, and we just get z would be negative 4. So we could write our answer negative 2 comma 3 comma negative 4. Problem number 10, we're asked to divide using long division. And the problem says 8x to the third plus 6x squared minus 5x plus 2 divided by 2x plus 1. Now when we divide, we write the divisor in front, and we are dividing into 8x to the third plus 6x squared minus 5x plus 2. Remember, when we multiply, we have to change the sign also. So 2x times 4x squared gives me 8x to the third, and then 4x squared, but like I said before, we have to subtract or change those signs. And the process starts over with 2x squared, and then bring down the negative 5x. 2x times x gives us 2x squared plus x. Changing those signs, we get negative 6x plus 2. And then starting this process over again, 2x times negative 3 gives us negative 6x minus 3, and changing those signs, we get a remainder of 5. So our final answer would be 4x squared plus x minus 3, plus the remainder divided by 2x plus 1. Problem number 11. We are asked to factor 90 x squared plus 480 xy plus 640 y squared. Now when we factor, first we have to start with a GCF, and we could take out a 10 from all of these factors. So we just get 9x squared plus 48xy plus 64y squared. And I noticed that 9x squared is actually just 3x squared. 64y squared is 8y squared. And 48 would be 2 times 3x times 8y. So this is one of the shortcuts we talked about in class. This would factor to be 10 times 3x plus 8y to the second power. The formula I'm referring to is if you have a plus b squared, this will multiply out to be a squared plus 2ab plus b squared. And if this was a minus between them, we would get a squared minus 2ab plus b squared. This has all positive, so we're going to be using this first formula. Problem number 12, it says 27 x to the third minus 1. And again, we're asked to factor it. And this is an example of the SOAP formula we discussed. So with the SOAP formula, we have to figure out what cubed is 27x to the third, and obviously that's 3x. 1 cubed is 1. So according to our formula, we're going to factor this to be a squared, ab, and b squared with the same sign, opposite, and always positive. So in factored form, this would be 3x minus 1 times 3x to the second power plus 3x times 1 plus 1 squared. But just make sure you put this in parentheses because it's not 3x squared, it's the quantity 3x to the second. So our final factored form would be 3x minus 1 times 9x squared plus 3x plus 1. And then we're going to finish with some word problems. Problem number 13 says you invested $5,000 in stocks and bonds. Stocks gave you 6%, and bonds gave you 10%. Your total return was $428. How much did you invest in each? Okay. So we're looking for the return on stocks plus the return on bonds, and that'll equal our total return. Well, in order to figure out return, we need a percent times a principal. And our total return was $428. So stocks were 6% times our principal, which we don't know, and bonds were 10% times the principal. We still don't know, but I know that however much we spend in stocks, if we subtract that from 5,000, that'll give us our principal in bonds. So all we have to do is combine like terms and simplify, and let's see what the answer is. Combine our like terms. Bring the 500 over. And then divide by negative 0.04. And that gives us a balance for stocks of $1,800. And remember, bonds would be however much is left over when we subtract that from 5,000. So 5,000 minus 1,800 is $3,200. Next word problem. Traveling for 3 hours against the wind, plane flies 1,500 miles. The return trip with the wind took 2.5 hours. Find the speed of the plane in still air. Well, it looks like we're flying against the wind and we're flying with the wind. Now, against the wind, if distance is equal to rate times time, we took 3 hours, and our speed is going to be the speed of this plane in still air minus the wind. And that's 1,500 miles. With the wind, we're still flying 1,500 miles, but we're taking the speed of the plane and it's increased by the speed of the wind, and that only took 2.5 hours. So if we distribute the 3 here, 3r minus 3w is equal to 1,500, and 2.5r plus 2.5w is equal to 1,500. If we do elimination, we should be able to get the answer. So if we're going to eliminate these, let's write them vertically. So 3r minus 3w is equal to 1,500, and 2.5r plus 2.5w is equal to 1,500. I'm going to multiply everything on top by 2.5, and I'll multiply everything on the bottom by 3. And what this gives us is 7.5r minus 7.5w is equal to 3,750, and 7.5r plus 7.5w is equal to 4,500. So therefore, we could eliminate the w's. We get 15r is equal to 8,250, and the speed of the plane in still air is 550 miles an hour. And then if we want to find the speed of the wind, 3r minus 3w is equal to 1500. I'm just going to replace r here by 550. And this gives me 1650 minus 3w is equal to 1500, or negative 3w is equal to negative 150. So the speed of the wind is 50 miles an hour. There's one more problem to do, and this is number 15. Problem number 15, it says a rectangle is 6 inches longer than its width. The area is 216 square inches. Find the dimensions. So just like we usually do, let's draw a picture. We have a length and a width, and it says it's 6 inches longer than its width, so the length would be the width plus 6, and the area is 216 square inches. Area is equal to length times width, so 216 would equal the length times the width. So if we distribute this, and then we want to solve this equation, so we can go ahead and make it equal to 0. When we go to factor this now, we need numbers that multiply to negative 216 and add up to 6. So it might take you a little while to land on it, but I believe that 18 and negative 12 get the job done. So if we factor using those numbers, cut it down the middle, we could take out a w here. We could take out a negative 12 in the second grouping. GCF is w plus 18. We're left with w minus 12. And then making each factor equal to 0, we get w would be negative 18, and w would also be 12. Now it doesn't make sense to have a negative width, so the width for this rectangle would be 12 inches, and the length would be 6 more than that, which is 18 inches.